Welcome to my first video on linear regression, and I am Aisha. Right, simple regression analysis. What is regression? Regression analysis is a statistical tool for investigating the relationship between a dependent variable and one or more independent variables. By regression, we can predict or determine one quantitative variable by another quantitative variable. The most elementary regression model is called simple regression. Regression analysis is widely used for prediction and forecasting. We can use regression for several fields such as economics, management, life and biology, engineering science, chemistry, physics, and so on. The simple linear regression depends on two variables. Therefore, it is called bivariate. One variable predicted by another variable. A dependent variable. The variable to be predicted is called the dependent variable, and it is denoted as y. Independent variable. The predictor is called the independent variable or explanatory variable, and it is denoted as x. Simple linear regression used only for find a straight line relationship between two variables. But non-linear relationships and regression models with more than one independent variables can be explored by using multiple regression models. A simple regression analysis. In regression, there must have a relationship between two variables. Otherwise, we can't find a regression. Therefore, first of all, we must check the relationship between these two variables. So, by using scatter plot, you can get an idea regarding the spread of the variables. Here I have taken two variables which are height and weight. So, here height is x-axis and weight is y-axis. By using correlation coefficient, you can find the strength of the relationship between two variables. This is the correlation coefficient equation. It is denoted as R. Each value of the x variable denoted as xi, mean value of the x variable denoted as x bar, each value of the y variable denoted as yi, and mean value of y variable denoted as y bar. The value range is -2 to +1. A correlation of -1 shows a perfect negative correlation, and +1 shows a perfect positive correlation. Simple linear regression. A simple linear regression is used to estimate the relationship between two quantitative variables. You can use simple linear regression when you want to know how strong the relationship is between two variables, the value of the dependent variable at a certain value of the independent variable. The assumptions of the simple regression analysis. We make a few assumptions when we use linear regression to model the relationship between a response and predictor. These assumptions are essential conditions that should be met before we draw inferences regarding the model estimates or before we use the model to make prediction. Here the first assumption is linear relationship, second one is independency, third one is homoscedasticity, and fourth one is normality. Because we are fitting a linear model, we assume that the relationship really is linear and that the errors or residuals are simply random fluctuations around the true line. We assume that the variability in the response doesn't increase as the value of the predictor increase. This is the assumptions of equal variance. We also assume that the observations are independent of one another. Correlation between sequential observations or autocorrelation can be an issue with time series data, that is, with data with a natural time ordering. How to check regression assumptions? We examine the variability left over after we fit the regression line. We simply graph the residuals and look for any unusual pattern. Simple linear regression equation. In regression analysis, we make the distinctions between the sample and the population. It is inconvenient to collect data for the whole population. We usually base our analysis on a sample. Using this sample, we try to make inference on the population. That is, we try to find the value of the parameters that correspond to the population. Therefore, it is important to understand the distinction between the population regression equation and the sample regression equation, where y is determined as the dependent or study variable and x is termed as the independent or explanatory variable. The terms beta 0 and beta 1 are the parameters of the model. The parameter beta 0 is termed as an intercept term, and the parameter beta 1 is termed as the slope parameter. These parameters are usually called as regression coefficients. How to find beta 0 and beta 1 parameters? These are the equations for beta 0 and beta 1. This regression model is developed by producing the minimum sum of square error values. This is called least square method. Here I have taken an example. This is x variable and this is y variable. The mean value of x is 70 and mean value of y is 50. So the beta 1 value is 1.4, beta 0 value is minus 48. So the regression equation is y equal minus 48 plus 1.4x plus residue. Coefficient of determination. The coefficient of determination tells one how well the data fits the model, the goodness of fit. The coefficient of determination is a statistical measure in a regression model that determines the proportion of variance in the dependent variable that can be explained by the independent variable. The value for R square can range from 0 to 1. A value of 0 indicates that the response variable cannot be explained by the predictor variable at all. A value of 1 indicates that the response variable can be perfectly explained without error by the predictor variable. And this is the coefficient of determination equation. R square equal sum of square regression divided by sum of square total. F-test of overall significance. The F-test of overall significance in regression is a test of whether or not your linear regression model provides a better fit to a database than a model with no predictor variables. The F-test of overall significance has the following two hypotheses. Null hypothesis at 0. The model with no predictor variables fits the data as well as your regression model. Alternative hypothesis HA. Your regression model fits the data better than the intercept only model. When you fit a regression model to data set, you will receive a regression table as output, which will tell you the F statistic along with the corresponding p-value for that F statistic. If the p-value is less than the significance level you have chosen, common choice are 0.01, 0.05 and 0.10, then you have sufficient evidence to conclude that your regression model fits the data better than the intercept only model. I hope you enjoyed this tutorial and I hope you learned something. Thank you.